Understanding coastal environments. Classifying coasts. Imagine standing at the edge of the land where it meets the ocean. This place, where the land and water come together, is called the coast. Now, think about how we might describe or classify these coasts. This can be tricky because coasts are studied by many different types of scientists, each with their own way of thinking about them. Also, coasts can be big or small and change over time, so describing them isn't simple. Why is classifying coasts hard? 1. Different interests. Some scientists study the land and how it's shaped, like hills and beaches. Others focus on the water or the animals that live there. Because of these different interests, each group might classify coasts in a different way. 2. Different sizes. A coast could be as small as a single beach between two rocky points, headlands. It could also be as big as the entire coastline of a continent, like the coast of North America. This means coasts can be looked at on different scales or sizes. 3. Different time periods. Some changes on the coast happen in just a few days or years. Other changes take hundreds, thousands, or even millions of years. For example, a beach might shift after a big storm, a short time, or a coastline might change because of glaciers melting over thousands of years. A simple way to describe coasts. A scientist named Rhodes W. Fairbridge came up with a simple way to describe coasts using 3 main ideas. 1. Coastal material. What is the coast made of? Is it made of hard rock, like cliffs, or soft sand, like a beach? Is the material something that can dissolve in water, like chalk, or not, like granite? Example, the White Cliffs of Dover in England are made of chalk, which is soft and can dissolve in water. A beach in Florida might be made of soft sand that easily moves with the waves. 2. Coastal agencies. What forces are shaping the coast? These could be natural forces like waves, erosive, or living things like plants and animals, biological. Also, where is the coast? Is it in a place where it gets hit by big waves all the time, like a coast with strong exposure, or is it in a quiet bay with little wave action, like a coast with low exposure? Example, the coast of California has strong waves, erosive, that carve out cliffs. Mangrove forests in tropical areas, biological, help build up the coast by trapping sediment with their roots. 3. Historical factors. How has the coast changed over time? Have there been earthquakes, geotectonic, or has the sea level risen or fallen, eustatic? What about the impact of humans, like building cities or seawalls? Example, the coast of Japan has changed due to earthquakes, which can cause the land to rise or fall. Some coastal areas, like parts of the Netherlands, have been heavily modified by humans to keep the sea out. Putting it all together. To fully understand and describe a coast, you need to think about what it's made of, coastal material, what's shaping it now, coastal agencies, how it's changed over time, historical factors. Additional simplification. Imagine building a sandcastle at the beach. The sand is your coastal material. The waves that wash over it and the wind blowing the sand around are your coastal agencies. If you came back the next day and saw that the sandcastle was gone, maybe due to the tide or someone stepping on it, that's a simple version of historical factors. When scientists describe coasts, they use similar ideas, just on a much bigger scale and over longer periods. In summary, coasts are complex and can be described by what they're made of, what shapes them, and how they've changed over time. This helps scientists understand and protect these important areas. Let's dive into waves in the simplest way possible. What are waves? Waves are the moving ripples you see on the water. They're caused by the wind blowing across the surface. How do waves form? 1. Wind blows on water. Wind pushes water. When the wind blows over the surface of the water, it pushes and creates ripples. Energy transfer. The wind gives its energy to the water, making waves. 2. Factors affecting waves. Wind speed. Stronger wind makes bigger waves. Wind duration. Longer winds create bigger waves. Fetch. This is the distance the wind blows over the water. The longer the fetch, the bigger the waves. Types of waves. 1. Sea waves. What they are. These are the waves you see where the wind is blowing. Characteristics. They have short tops, crests, and are often rough. 2. Swell waves, what they are. As sea waves move away from where the wind is blowing, they become smoother and travel longer distances. Characteristics, they have long, smooth tops and can travel far across the ocean. How waves move. 1. Oscillatory waves. In deep water, water particles move in circles. Movement, crest, the top part of the wave moves forward. Front, moves up. Trough, the bottom part moves backward. Back, moves down. Effect, the wave's shape changes, but the water doesn't move much in the direction of the wave. 2. Solitary waves. What they are. Big single waves that don't have the same circular movement as oscillatory waves. Movement. Water moves directly with the wave. Appearance. They look like tall single waves on flat water. Waves near the shore. 1. Wave refraction. What happens? When waves come close to the shore, the water gets shallower. Effect. The part of the wave in shallow water slows down, while the part in deeper water keeps moving fast. This bends the wave so it aligns more with the shore. 2. Wave breaking. Types. Spilling breakers. Foam spills down from the top. Plunging breakers. The wave curls over and crashes down. Collapsing breakers. The wave peaks and then crashes as a thin layer of foam. Surging breakers. The wave slides smoothly up the shore. Effects. Spilling and surging. These add sand to the beach. Plunging and collapsing waves. These take sand away from the beach. How waves affect the beach. Constructive waves. Characteristics. Strong push up the beach and gentle pull back. Effect. Build up the beach by adding sand and pebbles. Destructive waves. Characteristics. Short push up the beach and strong pull back. Effect. Pull sand and pebbles away from the beach, causing erosion. Summary. Waves are created by the wind and can vary in size and shape. Sea waves are rough and irregular. Swell waves are smoother and travel longer distances. Oscillatory waves move in circles in deep water, while solitary waves move directly. Near the shore, waves change shape, break, and either build up or erode the beach. This should give you a clear understanding of how waves and their effects on the coast. All right, let's break down the concept of tides in the simplest way possible, step by step. What are tides? Tides are the rise and fall of sea levels. They are mainly caused by the gravitational pull of the moon and the sun on the Earth's water. How do tides work? 1. Gravitational pull. The moon's gravity pulls on the Earth's water, creating a bulge or rise in the water on the side of the Earth closest to the moon. This is high tide. There's also a bulge on the opposite side of the Earth due to the centrifugal force as the Earth and moon orbit around a common point. This is another high tide. In between these bulges, the water level is lower, and this is low tide. 2. Types of tides. Semi-diurnal tides. Most places on Earth experience 2 high tides and 2 low tides every day. These are called semi-diurnal tides. Diurnal tides. Some places, like the Antarctic coasts, have only 1 high tide and 1 low tide each day. These are called diurnal tides. Mixed tides. In some areas, especially around the Pacific Ocean, the 2 daily high and low tides are not equal in height. These are called mixed tides. Special types of tides. 1. Spring tides. These happen when the Earth, moon, and sun are in a straight line, aligned. The gravitational forces of the moon and the sun combine, pulling the water in the same direction, which makes the high tides higher and the low tides lower. Spring tides occur every 2 weeks, about every 14 to 15 days. 2. Neap tides. These occur when the sun and moon form a right angle, 90 degrees, with the Earth. The gravitational pulls from the sun and moon work against each other, making the high tides lower and the low tides higher. Neap tides also occur every 2 weeks, alternating with spring tides. Factors affecting tides. The shape and size of the ocean basin, the large depressions in the Earth's surface that contain the oceans, can affect how high or low the tides get. The shape of the shoreline and even the weather can influence the tides. Tidal ranges. The tidal range is the difference in height between high tide and low tide. Microtidal, when the difference is less than 2 meters, small tidal range. Mesotidal, when the difference is between 2 to 4 meters, medium tidal range. Macrotidal, when the difference is more than 4 meters, large tidal range. Tidal bores. In some places with large tidal ranges, such as the Severn Estuary in England, a strong, fast-moving wave called a tidal bore can form. This happens when the tide moves into a narrowing river or bay, creating a wave that can travel up to 30 kilometers per hour and cause significant erosion. Tidal currents. Tidal currents are the movements of water caused by the rising and falling tides. Flood currents. These occur when the tide is rising. Ebb currents. These occur when the tide is falling. These currents can be strong, especially in narrow places like estuaries, where they can transport and erode sediment. Summary. Tides are the regular rise and fall of sea levels, caused by the gravitational pull of the moon and the sun. There are different types of tides, semi-diurnal, diurnal, and mixed, and special tides, spring and neap tides. Tidal ranges vary and have significant effects on the coastline, including the formation of tidal bores and tidal currents. This is how tides work on its coastlines. Absolutely. Let's break it down even further, making it super simple to understand. Act 1. Coastal processes. What happens at the shore? The shore is the place where the land meets the sea. It's always changing because of forces from nature, like waves and weather. These forces can do two main things: break down the land, called degradational processes; build up the land, called aggradational processes. We'll talk about the first one, how the land gets worn down or broken. 2. Shoreline weathering, how the shore's rocks get worn down. Weathering is when rocks on the shore break apart or wear down over time. There are several things that cause this to happen on the shore, and they work together to change the coastline. 2.1. How seawater wears down rocks. Seawater is full of salt and other stuff. When it touches rocks, it can start to wear them away, especially if the rocks are made of certain materials like limestone. Example: imagine if you keep dipping a sugar cube in water. Slowly, it would start to dissolve and disappear. That's what seawater can do to some rocks. 2.2. Salt weathering. How salt cracks rocks. When seawater splashes onto rocks, some of it soaks into tiny cracks in the rock. As the water dries, it leaves behind salt crystals. These crystals grow and push the cracks wider, breaking the rock apart. Example: think of what happens if you leave a wet sponge in the sun. As it dries, it might start to crack. Salt weathering does something similar to rocks. 2.3. Wetting and drying. How tides break rocks. The shore is always getting wet and then drying as the tide goes in and out. When rocks get wet, they expand, get a little bigger. When they dry, they shrink. This constant expanding and shrinking makes tiny cracks in the rocks, which eventually grow bigger and break the rock apart. Example: imagine bending a piece of plastic back and forth. After a while, it snaps. The same thing happens to rocks that keep getting wet and then dry. 2.4. Bioerosion. How living things help break down rocks. Bioerosion is when plants and animals help break down rocks. Tiny plants like algae or fungi can produce chemicals that slowly eat away at rocks. Some animals, like certain snails or sea urchins, scrape the rocks with their teeth or shells to get food. This scraping wears down the rock over time. Example: imagine scraping your nails on a chalkboard. Over time, the board would start to wear down. That's what these sea creatures do to rocks. 3. Wave erosion. How waves break down the shore. Waves are one of the most powerful forces that change the shore. When waves hit the shore, they can break rocks, move sand, and change the coastline. 3.1. How waves attack the shore. Waves are made of energy. When they crash onto the shore, they hit the rocks and sand with a lot of force. If the rocks are hard, they resist the waves better. But if the rocks are soft, the waves can break them easily. Example: think of throwing a ball at a wall. If the wall is strong, it won't break. But if the wall is weak, it might crack. Waves are like that ball, hitting the shore again and again. 3.2. Plunging breakers. The most powerful waves. Plunging breakers are waves that crash down really hard on the shore. When these waves hit, they can trap air between the wave and the shore. The trapped air gets squeezed, creating a lot of pressure. This pressure can help break rocks apart. This process is called quarrying. Example, imagine blowing up a balloon and then squeezing it hard. The air inside the balloon pushes out and the balloon might pop. That's similar to what happens when waves trap air against the shore. 3.3. Wave abrasion. How waves throw sand and rocks against the shore. As waves move, they carry sand, pebbles, and even small rocks. When these hit the shore, they act like sandpaper, rubbing against the rocks and wearing them down. This is called abrasion. Example, if you rub a piece of sandpaper on wood, it smooths out the wood by wearing away the surface. The waves do something similar to rocks on the shore. 3.4. Bioerosion by sea creatures. Just like on land, some sea creatures help erode rocks underwater. Some animals, like clams and sponges, make tiny holes in the rock to live in. Over time, these holes weaken the rock, making it easier for the waves to break it down. Example, imagine poking a piece of wood with a sharp stick over and over. Eventually, you might create a hole, making the wood weaker. That's what these sea creatures do to the rocks. 4. Why it matters. Understanding coastal erosion. Coastal erosion is important because it changes the shape of the land we see at the beach. Over time, these natural forces can make beaches smaller, cause cliffs to collapse, and create new landforms. For people, if people live or build near the coast, they need to understand these processes because coastal erosion can make the land disappear, which could be dangerous for buildings, roads, or even homes near the shore. Final example to understand it all. Imagine you build a sandcastle at the beach. At first, it's strong and solid, but as the waves come in, they start to wash away the sand. The water soaks into the sandcastle, and as it dries, cracks form. Tiny crabs might even dig into it, making it weaker. Over time, your sandcastle crumbles and disappears. The same thing happens to real rocks and cliffs along the shore. They're slowly worn down by the waves, salt, weather, and even tiny creatures. This process changes the coastline, making it look different over time. Sure, let's go into more detail and keep it as simple as possible. Coastal erosional landforms. These are shapes or features on the coast formed by the action of waves and tides over time. They mostly occur along rocky coasts, but can also be found in places where sediment is deposited. Two main types. 1. Shore platforms. 2. Plunging cliffs. 1. Shore platforms. What they are. Shore platforms are flat or gently sloping surfaces found at the base of cliffs along the coast. How they form. 1. Cliffs and waves. Imagine a tall cliff facing the sea. Waves crash against the bottom of this cliff. The force of the waves breaks off pieces of the cliff and wears it away. 2. Flat or sloping surface. Over time, as the cliff gets worn down, it creates a flat or sloping area at the base of the cliff. This flat or sloping area is what we call a shore platform. Types of shore platforms. Horizontal shore platforms. Almost flat surfaces at the base of cliffs. They are called horizontal because they don't slope much. Sloping shore platforms. These have a gentle slope from the cliff base down towards the sea. They are called sloping because they tilt downward. Examples. Flat rock shelf. Think of a large, flat rock shelf you might find at the base of a cliff on the coast. Gentle slope. Imagine a gently sloping area that leads from the cliff base to the water. 2. Plunging cliffs. What they are. Plunging cliffs are steep cliffs that drop directly into the sea without any flat area at the bottom. How they form. 1. Cliff formation. These cliffs are usually very steep. They don't have a flat platform at the bottom. 2. Sea level changes. Plunging cliffs often form when the sea level rises or when the land around the cliff sinks. This can cover any flat platforms that might have been there before. Examples. Straight drop. Imagine a steep cliff where the rock drops straight into the ocean with no flat area at the bottom. Key points. Erosion. The process where waves wear away the land. Shore platforms. Flat or sloping areas at the base of cliffs created by erosion. Steep cliffs that drop straight into the sea, often due to changes in sea level or land sinking. Summary. Shore platforms. Created by waves hitting and eroding the base of cliffs, resulting in flat or sloping surfaces. Plunging cliffs. Steep cliffs that go straight into the sea, formed by changes in sea level or land height. Simple visual. 1. Shore platform. Think of a flat or gently sloping rock area at the base of a cliff. 2. Imagine a tall, steep wall dropping directly into the ocean with no flat area at the bottom. By understanding these basic concepts, you can see how different coastal features are shaped by the natural forces of the sea. Let's break down the different landforms that you find on rocky coasts. We'll look at cliffs, notches, ramps, and other features. 1. Cliffs. What they are. Cliffs are very steep or vertical rock faces that rise high above the sea or a shore platform. How they form. Cliffs are made when waves hit the base of a rocky area, causing the rock to break and wear away. Over time, the cliff gets steeper as more rock is worn away at the bottom. Example, think of a tall wall of rock by the sea that looks like it drops straight into the water. That's a cliff. 2. Notches. What they are. Notches are small, shallow indentations or grooves at the base of a cliff. How they form. Notches form when waves and water erode, wear away the base of a cliff. The amount of erosion depends on how strong the rocks are, how powerful the waves are, and how much material like sand or pebbles is hitting the cliff. Example, imagine a small dip or groove at the bottom of a tall rock wall where the waves have worn away some of the rock. 3. Ramps. What they are. Ramps are sloped areas found at the base of cliffs. They are steeper than the flat shore platform, but not as steep as the cliff. How they form. Ramps form when erosion at the base of the cliff creates a sloping surface that leads from the cliff to the sea. Example, picture a gentle slope at the bottom of a cliff leading down to the water. It's like a natural ramp. 4. Ramparts. What they are. Ramparts are small ridges or raised areas on a shore platform. They are usually about 1 meter high. How they form. Ramparts form at the edge of a shore platform where the waves have deposited materials. Example, imagine a low, rocky ridge on the flat area of a shore platform where the sea has pushed rocks and debris. 5. Marine potholes. What they are. Marine potholes are bowl-shaped or cylindrical depressions in the shore platform. How they form. Potholes are created when waves swirl around small stones and gravel, grinding out these bowl-shaped holes in the rock. Example, think of small round holes in a rock surface, created by the swirling action of sand and pebbles carried by the waves. Additional features. Arches, formed when waves erode through a cliff, creating a natural archway. Stacks, tall, isolated columns of rock left standing after the surrounding cliff has eroded. Caves, formed by waves eroding the base of a cliff, creating a hollow area. Summary. 1. Cliffs, steep rock faces by the sea. 2. Notches, small indentations at the base of cliffs. 3. Ramps, sloped areas at the bottom of cliffs. 4. Ramparts, small ridges on flat shore platforms. 5. Marine potholes, bowl-shaped holes in shore platforms formed by swirling sand and gravel. Simple visuals. Cliff, a tall wall of rock. Notch, a small dip at the bottom of a cliff. Ramp, a gentle slope at the cliff base. Rampart, a low ridge on a flat rock surface. Pothole, a round hole in a rock from swirling water. These features are all part of how the coast gets shaped by natural forces like waves and tides. Let's break down these coastal landforms and how they form using simple language. 1. Sea caves. What they are. Sea caves are hollow spaces or tunnels carved into cliffs by waves. How they form. Waves hit the cliff and erode, wear away weaker parts of the rock like joints or faults. Over time, this erosion creates a hollow or cave in the cliff. Example, Fingal's Cave on the Isle of Staffa in Scotland. It's a sea cave formed in basalt rock and is 20 meters high and 70 meters long. 2. Blowholes. What they are. Blowholes are openings in the roof of a sea cave where water shoots up like a fountain. How they form. When waves crash into the cave, they force air and water up through cracks in the cave roof. If these blowholes get bigger, they might collapse. Example, Lion's Den on the Lizard Peninsula in Cornwall, England, has a blowhole where water sprays up from the cave. 3. Sea arches. What they are. Sea arches are natural rock arches that form when waves erode through a promontory, a piece of land that sticks out into the sea. How they form. Waves attack both sides of a promontory, eroding it until a hole forms and eventually becomes an arch. Example: Merlin's Cave at Tintagel in Cornwall, England, is a sea tunnel created along a fault line. It's 100 meters long. 4. Sea stacks. What they are. Sea stacks are tall, isolated columns of rock that remain after the arch above them collapses. How they form. When a sea arch collapses, it leaves behind a stack, which is a solitary rock tower. Example: Old Hairy Rocks in Dorset, England, are a group of sea stacks that were once part of a larger rock formation. The Old Man of Hoy in Scotland is a 140-meter-high stack separated from cliffs by erosion. 5. Gorges. What they are. Gorges are deep, narrow valleys with steep sides formed by erosion along weaknesses in the rock. How they form. Gorges can form in places where rock layers are weak and easily eroded, or from the collapse of tunnels or dikes, volcanic rock formations. Examples: geos or yawns in Scotland are types of gorges. Zounds are gorges found on the granitic peninsula of Land's End in Cornwall, England. Summary of coastal landforms. 1. Sea caves, hollows in cliffs made by waves eroding weak rock. 2. Blowholes, openings in sea cave roofs where water sprays out. 3. Sea arches, natural arches formed by waves eroding through a promontory. 4. Sea stacks, tall columns of rock left after a sea arch collapses. 5. Gorges, deep, narrow valleys created by erosion along weak rock layers. Simple visuals. Sea cave, a hollow carved into a cliff. Blowhole, a spray of water shooting up from a cave roof. Sea arch, a rock arch over the sea. Sea stack, a tall, isolated rock tower. Gorge, a deep, narrow valley with steep sides. These landforms show how powerful and persistent the forces of waves and erosion can be in shaping the coast. Let's break down the concept of coastal depositional landforms and focus on beaches. I'll explain it step by step. What is a beach? A beach is a strip of land along the shore where sand, pebbles, or other materials gather. Beaches are shaped by the waves and tides of the ocean. They are places where the sea meets the land. Types of beach materials. Sand beaches, made of fine sand, common in tropical areas. Pebble beaches, made of small stones or pebbles, common in colder regions. Beach profile. The beach profile is the shape of the beach from the land to the water. It can change based on beach material. Sand or pebbles affect the slope. Tides. The level of the sea changes with high and low tides. Waves. Big or small waves shape the beach differently. Parts of a beach profile. 1. Berm. The flat area on the upper part of the beach where waves usually don't reach. It's the landward edge of the beach. 2. Beach face, the sloping part of the beach that stretches from the berm to the water. The slope depends on the size of the sand or pebbles. Fine sand beaches usually have a gentle slope, about 2 degrees. Pebble beaches can have a steeper slope, up to 20 degrees. Beach types, based on waves and tides. 1. Wave-dominated beaches. Dissipative beaches, found where there are strong waves, more than 2.5 meters high. They have a wide, gently sloping area with multiple bars, ridges of sand or pebbles. Reflective beaches, found where there are smaller waves. They are steeper and narrower. Example: dissipative, a beach with gentle waves, like some in Australia. Reflective, a beach with steeper slopes, often found where the waves are less powerful. 2. Tide-modified beaches, reflective plus low tide terrace. Found where there are big tides, the difference between high and low tide. They have medium sand and steep slopes. Ultra-dissipative beaches have very wide intertidal zones, the area between high and low tides, and gentle slopes. They experience a lot of wave energy. Example: ultra-dissipative, beaches with very wide sandy areas, such as some beaches in tropical places. 3. Tide-dominated beaches. Reflective plus ridged sand flats, found where the tides are very large compared to the waves. They have flat, sandy areas. Beach plus tidal flats includes beaches that transition into flat, mud-covered areas. Example: tide-dominated, beaches with large tidal flats, such as some estuarine regions. Summary. 1. Beaches are where the sea meets the land and are made up of sand, pebbles, or other materials. 2. Beach profile includes the berm, upper flat part, and the beach face, slope leading to the water. 3. Types of beaches. Wave-dominated, shaped by wave strength, can be dissipative or reflective. Tide-modified, shaped by the range of tides, includes reflective plus low-tide terrace and ultra-dissipative beaches. Tide-dominated, shaped by large tides compared to waves, includes reflective plus ridged sand flats and beach plus tidal flats. These landforms help us understand how waves and tides shape the coastlines over time. Let's break down the coastal landforms of spits, barriers, and related features into simple parts. What are coastal accumulation landforms? Coastal accumulation landforms are shapes made by the buildup of sand, pebbles, or other materials along the coast. They form when more material is deposited than is washed away. Where do these landforms form? 1. Obstructions, features like rocks or reefs that block the movement of sediment. 2. Coastline turns, places where the coastline changes direction, causing sediment to gather. 3. Sheltered areas, protected spots between islands and the mainland where waves are less strong. Types of coastal accumulation. Landforms. 1. Spits. Appearance, like a long, narrow finger of sand stretching out into the sea. Attachment, stuck to the mainland at one end but open at the other end. How they form. Sediment moves along the coast with the waves and builds up where the direction changes or slows down. Example, Spurn Head in England. 2. Forelands. Appearance, wider than they are long, forming a broad area sticking out. Attachment, attached to the mainland at one end. How they form. Similar to spits, but have a wider base, often forming in areas where sediment builds up more quickly. Example, the foreland of the Isle of Portland in England. 3. Barriers, looped barriers. Appearance, long and curved strips of land that are attached to the mainland at both ends. How they form. Sediment builds up in a loop or curve, separating a part of the sea from the open water. Example, the Outer Banks in North Carolina. Cuspate barriers, shaped like a triangle or cusp, sticking out from the coast. How they form, created where sediment from two directions meets and builds up. Example, Cape Hatteras in North Carolina. Tombolos, appearance, a strip of land connecting an island to the mainland. How they form. Sediment builds up to join an island with the mainland. Example, the connection between the Isle of Portland and mainland England. Barrier beaches, appearance, long and narrow beaches connected to the mainland at both ends. How sediments up parallel to the coast, creating a beach that protects the land behind it from strong waves. Example, Long Island in New York. 4. Barrier islands. Appearance, long and narrow islands separated from the mainland on both ends. How they form, built up by sediment parallel to the coast, creating a strip of land in the sea. Example, the Florida Keys in the United States. Summary, spits are long, thin strips of sand attached to the mainland at one end. Forelands are wider, broader strips of land attached at one end. Barriers include different types like looped barriers, cuspate barriers, and tombolos, often attached at both ends or connecting islands. Barrier islands are long, thin islands that are separate from the mainland. These landforms help shape our coastlines and can affect how waves and currents move along the shore.